Alright, lesson 1 for Unit 3 is going to be establishing our foundation for parallel lines and their relationships. So we're going to look at some definitions to set off our foundation for the unit. We're going to talk about different types of lines as well as different types of angles that you can have with these lines we're going to be talking about. So you have your words down here in the word box, and then we're just going to be matching them to the definitions. So our first definition would be coplanar lines or planes that never intersect. So let's break this down a little. Coplanar means that they're in the same plane, so that's only referring to the lines. So we have lines that are in the same plane, or two planes themselves, that will never intersect. That means that they never touch. Our word for that is parallel. So we can have parallel lines or parallel planes. This little diagram right here is the lines representation. So we have two lines like this, and the way that we know that they're parallel, well, it's obviously the fact that they're not touching, but to specify that they're never going to touch, even if you continue on forever, are these little arrow symbols. So they can be arrows, or they could also be triangles. It just depends on what the picture wants to use. But those little markings mean that these lines are parallel. They do not mean that the lines are congruent. Remember, congruent is a little hash mark. These are little arrows. It means that they're parallel, but parallel lines do not have to be congruent, so make sure you don't confuse those symbols. And then in directions, like if I wanted to say that lines are parallel and I wanted to swap the word parallel for a symbol, this is the symbol that represents parallel. So I can say line AB is parallel to line DC. And so this represents the word parallel. So that's parallel lines and planes. Planes can also be parallel if you imagine two pieces of paper right next to each other. Kind of if you hold one in your right hand and hold one in your left hand so that they're both floating in air but not touching. That's essentially a good representation of planes that are parallel. They're not touching. The next definition is for skew lines. Skew lines are non-coplanar lines that never intersect but are not parallel. So non-coplanar means that they're not in the same plane. That's why they're not parallel. For lines to be parallel, they have to be coplanar and not touching. For them to be skew, they are non-coplanar and not touching. So non-coplanar means that they're not in the same line. Sorry, they're not in the same plane. So if you can imagine like a vertical line on a piece of paper and then a horizontal line on a different piece of paper that is a little bit off to the side, those would be skew. They're going in different directions and they're in different planes, so they're never going to touch. If you want to, I know it's a little bit hard to draw representation because it needs to be 3D. So if you Google skew lines, they may be able to give you a good representation of the 3D skew lines on Google somewhere. Our next definition is perpendicular. Perpendicular lines or planes are lines or planes that intersect to form right angles. So here's a representation of two lines that are perpendicular. You notice the 90-degree angle symbol right here, the little box. They're only going to draw one, though officially all four of these angles are right angles, but they're not going to put a box for all four of them. They're just going to put it for one. So if you see one box, you know that all the rest of them are going to be 90 degrees as well. They're just not going to put the symbol there. And the same thing, planes can be perpendicular the same way that lines can be. So if you imagine two pieces of paper that are crossing like this, kind of one piece of paper slicing through the other one, they can still cross to create 90-degree angles too. So both planes and lines can be perpendicular. And then this is the symbol for perpendicular that you would use in a sentence. So if you wanted to say AB is perpendicular to DC, you would use the symbol right here. All right, a transversal. A transversal is a line that intersects two or more other lines at different points. So these two black lines I had originally, and then once you draw the red line, it crosses the two black lines at two different points. The red line is the transversal. So if you have some lines already drawn, and then you draw another line through them so that it crosses them, two or more different lines, that line is a transversal. And that's going to be an important idea for when we get to the angles on the next page. You want to make sure you understand which line in this picture is a transversal, because it's going to be important later. Alright, we're going to transition from lines to angles now. So those are all the different types of lines you need to know. Now we're going to talk about a bunch of different types of angles. So you'll notice I have all these diagrams. All these angles we're going to be talking about involves a transversal. Notice that word shows up in all these definitions. So all these angles that we have are going to be created when you have two lines like this and then a transversal crossing the two lines. So it makes kind of like an H shape. It doesn't have to be an H, right? Sometimes the lines can be more slanty and make an A shape where the two ends are crisscrossing. But if you stick with the H idea, it does tend to make it a little bit easier to work with. So we're going to use this picture to help illustrate the idea. So the first type of angles we're going to talk about are called interior angles. Interior angles are angles that are inside or between the two lines that are being crossed by the transversal. So these are the two lines, the black ones are the ones that are being crossed by the transversal. So any angles that are on the inside are going to be called interior. So I've drawn blue dots for the interior angles. So all these angles on the inside are in between the two lines. Those are interior. Now we have two different types of interior angle pairs that we're going to talk about. So we have alternate interior angles. These are interior angles, a pair of them, so two interior angles that are diagonal from each other and lie on opposite sides of the transversal. So if you take a look, I did some color coding. They still have to be inside of the two lines here, right? But they're diagonal or across from each other. One is on the top of the transversal, the other one is on the bottom of the transversal. So if you have that zigzag kind of diagonal pattern here, these are going to be considered alternate interior. There's another pair of alternate interior right here with the orange. So there are two pairs of alternate interior, the blue and the orange. As long as they're on different sides of the transversal, then they're going to be considered alternate. And they're interior because they're inside of the two lines. We also have consecutive interior angles. Consecutive interior angles are interior angles, or two interior angles, that lie on the same side of the transversal. So alternates are on different sides of the transversal. Consecutive are on the same side. So these angles are both below, and these are both above the transversal. So instead of being diagonal, they're on the same side. So consecutive angles, interior, they're still inside, but they're on the same side of the transversal. Okay? So two different types of relationships with our interior angles, the alternate and the consecutive. Now we're going to talk about exterior angles. Exterior angles are outside the two lines that are being crossed by a transversal. So again, we have our two lines here and our transversal. We don't want interior anymore. The exterior angles are now on the outside. So exterior angles are going to be outside of the two black lines, the lines that are being crossed by the transversal. Pretty straightforward, right? Inside versus outside. We're going to see the two types of angles we saw before again, but we're going to do the exterior version now. So we had alternate interior, now we have alternate exterior. So again, it's going to be two exterior angles that are diagonal from each other on opposite sides of the transversal. So they have to be outside, but they're also diagonal from each other. So one's on top, one's on bottom, but they're both outside because they're exterior angles. Same thing over here, one's on top, one's on bottom. They're diagonal. We also have the consecutive version. So they're still outside, they're still exterior, but they're on the same side of the transversal, both on top or both on the bottom. Okay, so we have the same kinds of relationships with the alternate and consecutive. It just depends on whether they are inside or outside. The last relationship with angles we're going to talk about is called corresponding. Corresponding angles are angles that lie in matching positions at each intersection of the transversal. So there are four pairs of corresponding. The blue angle is here. This is in the upper left-hand corner at this intersection, and this angle is at the upper left-hand corner of this intersection. If they're in the same matching positions in both intersections, those are called corresponding. The green are in the upper right-hand corners, the orange are in the lower left-hand corners, and the purple are in the lower right-hand corners. So you'll notice that this little crossing should look identical to this crossing with the color coding. That's how corresponding angles work. There's no interior or exterior, right? That's just these up here. Corresponding is its own idea. So matching positions. All right, we're going to practice with lines with this activity, and then we're going to practice angles on the next page, okay? So let's take a look at the lines. This first question is asking us to name all segments that are parallel to, hold on, let me get my pen out. Okay, all segments parallel to VZ. So that's going to be this segment right here. So notice how we have these little triangle symbols. Remember I introduced in the notes up here that these symbols represent parallel. So we're going to look for all the lines that also have the same symbols on them. So this is a double arrow, so I don't want to use the single arrow ones. I'm going to use all the ones that have double arrows. And so the lines that would be parallel to this segment that I've highlighted would be SW, TX, and UY, because they all have this matching symbols here. They're all parallel. They're edges of a cube. They're all vertical. Now, let me go ahead and erase that. Now we're going to look at all segments that are perpendicular to UY. So now perpendicular is no longer parallel. It's going to be creating 90-degree angles with this right here. So if you imagine a cube, we can see a 90-degree angle right here. So I automatically know that this side right here is going to be perpendicular because they create this 90-degree corner. I also know that this side is going to do that because it also creates a 90-degree corner. Now you'll notice in the picture that these are the only 90-degree angles that we have drawn in the picture here, but there are actually two more sides that are perpendicular to UY, and they are TU and XY. Now the easiest way to understand this is if you guys have a tissue box at home or anything that's a cube or rectangular prism type shape, if you think about a corner of a cube, you have that 90-degree angle right here with this side, but you also create the corner using this side. You need both of these two sides together to create the corner at U, and these two sides to create the corner at Y. You can't have that 90-degree corner box shape unless you have both of these sides. So I know I don't have another little box for the 90-degree angle in either of these positions, but using the 3D format of a cube or a prism, we know that those sides are also going to be perpendicular. So the answer would be all four of these segments right here. And that will always be true when you're talking about a perpendicular line in a shape like this. You're going to have two perpendiculars at each corner to create that point for your shape. This next one says name a plane that's parallel to STU. STU is right here. It's the top of the box. I want a plane that's parallel to that. The only side that's parallel to the top is going to be the bottom. Okay? So the two planes here, the top and the bottom, are parallel. So you're just going to go ahead and name the bottom plane. You can use whatever letters you want. You have to use 3 or more, so you could technically use 4 letters if you wanted to. You do not have to, but I chose to use W, X, and Y. You could have said W, X, Y, Z. You could have said just X, Y, Z. It doesn't matter what order you put them in as long as you have at least 3 letters in the correct plane. Now I'm going to find a plane that's perpendicular to WXY. WXY is the bottom of the shape. So if I want planes that are perpendicular to that, if this is horizontal, perpendicular would be vertical. So I'm going to go around and I'm going to find all the vertical sides of my shape. And those are going to be perpendicular because they create that 90-degree edge along the bottom of my cube. So one of the planes that's going to be perpendicular is this one on the left. SVZ. I believe that's how I named it. Oh, I used W. SWZ. Right, that's the left side. I also know that the back vertical side right here is going to be perpendicular. The right side is going to be perpendicular, and the front side is going to be perpendicular. So I name all the different sides of the cube right here. and those are going to be all of the planes that are perpendicular to the bottom. Notice that it only says name a plane. I went ahead and wrote all of them just to cover all of our bases. But on a quiz or an assignment or something, if it just says name A, I don't need all of them. You can just pick one. But just to illustrate, I named all of them in the notes. Alright, next question. Name a transversal to segment SV. Let me go ahead and get my color out again. SV and WZ. So remember, a transversal is a line that crosses two or more other lines. So I have the two lines named already that I want to be crossed. So I just have to find the line that crosses both this line and this line. So if you look at the picture, we need to find a transversal that crosses this segment and this segment. So I only wrote one answer, I think. Oh no, there's two. So you could choose this line right here, right? This line is, if you keep drawing it, I know it's cut off because it's a segment, but if you were to keep drawing it like this, you can see that transversal property happening. It crosses, or it touches both of these lines. You can do the same thing for SW. If you kind of draw that line and see how it crosses both of the two lines in question, that makes it a transversal. Now it doesn't have to keep going, it can just stop where it touches the line and it's still considered a transversal. So don't think that it has to be a line, it can still be a segment that stops at the corner. That's fine. You just need it to touch at least two different lines at two different points. And that happens in our picture here. Alright, the next question says, how many lines are through S are perpendicular to XY? So, XY is right here, and S is right here. So they're asking, how many lines can you draw through S? So that means you have to have S in your line, so it could be SV, ST, or SW. I want to know how many of those would be perpendicular to XY. Well, remember the definition of perpendicular says that they have to intersect. That's part of the definition. So all the lines that go through S, like this, none of them touch XY. So that's actually not going to work for us. The answer would be none. Because we specified that it has to go through S, none of these lines that I drew that contain S, none of them even touch XY, so they can't be perpendicular. Okay? The last question on this page says, how many lines through W are parallel to UI? So UI is right here, and I want to know how many lines through W are parallel to this one. Well, the lines through W would be this one, and this one. The only line that's parallel to this one would be SW, because it has the same symbols for parallel, right? So there's only one line that is parallel to UI through W. Alright, so that was practice with lines. Now we're going to take a look at the angles. This is really the more important stuff that you guys need to know, because in lesson 2 and lesson 3, we're going to be talking about how to solve using angles and prove things using angles. So being able to recognize angle relationships is going to be super important. So make sure that you're paying very close attention and trying to understand this as best as you can. So in this picture right here, I have angles 1 through 8 all labeled, and we're going to identify all the angles that apply to these categories. So first of all, let's find the interior angles. So I'm going to use some color coding, and this is a really good strategy I recommend for you guys. I'm going to go ahead and trace the transversal in one color, and the other two lines that are being crossed by the transversal in a different color. So remember, I know this is the transversal because this is the line that's crossing the other two. All right, this line right here cannot be a transversal because it's only crossing one line. The transversal has to cross at least two lines. Alright, now that I know that, remember interior angles are angles that are inside or between the two lines that are being crossed. So the interior angles are going to be inside here. So our interior angles are 2, 3, 6, and 7. Exterior angles are the angles that are outside of the two lines that are being crossed. So these angles on the outside here are going to be my exterior angles, 1, 5, 4, and 8. Hopefully that makes sense, right? Inside versus outside. Once you have the lines traced, it's easier to see. And we're going to find corresponding angles. These angles work in pairs. Okay, so I was just identifying what the position for each angle. Now I'm going to link them together into pairs to find angles that are corresponding. So remember, correspond means that they're in matching positions. So if I start with angle 1, angle 1 is in the lower left-hand corner. If you look at these four angles, this is the lower left-hand corner. So if I want the angle that's corresponding, I have to go over here and find the angle that's in the lower left-hand corner as well. So I know that angle 1 and angle 3 are corresponding. Angle 2 is in the lower right-hand corner, so is angle 4 in this section of the diagram. So 2 and 4 would be corresponding, 5 and 7, and then 6 and 8 would also be corresponding. So again, you just pick one of the angles and you go to the same position in the other intersection and find the matching position, and you're good to go. Now we're going to talk about alternate exterior angles. So important to notice are these two words. Alternate, meaning that they're on different sides of the transversal, and exterior, which means they're on the outside of these two lines. Okay? So my exterior angles, we already said, were 1, 5, 4, and 8. So we have to match them up into pairs so that they're alternate. So alternate means that they are diagonal from each other, so they're on different sides of the transversal. So one needs to be below and one needs to be above. So I could start with angle 1, right? That's below the transversal. The alternate exterior would be angle 8. So below, above, and they're both exterior. So alternate exterior. Same thing for 5, which is above, and 4, which is below. They're diagonal, like this, on different sides of the transversal, and they're both exterior. So these are my two pairs of alternate exterior angles. Now I'm going to do the same thing, but with interior angles. So I want alternate still, which means they're diagonal or on different sides of the transversal. But now they're inside, so our inside angles are in here, interior. But I want them to be alternate, different sides of the transversal. So if I start with angle 2, angle 2 is below the transversal, so I want the other angle to be above the transversal, but it needs to be diagonal. Alright, so 2 and 7 are going to be a pair of alternate interior, and 6 and 3 are going to be a pair of alternate interior. They're diagonal from each other on different sides of the transversal. Alright, so we took care of our alternate angles. Now we're going to talk about consecutive. We're going to start with interior. So again, we're looking in between these lines. We're looking on the inside. But now we're doing consecutive, which means they're on the same side of the transversal. So if I start with angle 2, since I'm below the transversal, I'm going to stay on the underside of the transversal, and I'm just going to go across, not diagonally, but next to, or kind of following the pattern. I'm going to go over the, over to the other side of the shape with 3. So 2 and 3 are consecutive interior. Same thing with 6 and 7. So these are consecutive interior, same side of the transversal. Now we're going to do consecutive exteriors. Same idea, except the angles are on the outside now. So I'm going to be working with the angles on the outside, but they need to be on the same side of the transversal. So if I start with angle 1 is on the bottom, so I need to use angle 4, which is also on the bottom of the transversal, but they're both exterior. So consecutive exterior angles, oops, I gave it away, did it in the wrong order, sorry, angle 1 and angle 4, and then angle 5 and angle 8. 5 and 8 are both above the transversal, 1 and 4 are both below. So hopefully you guys can see the difference between when they're alternate, which is when they're diagonal, one's on the bottom, one's on the top, and consecutive, which is when they're on the same side of the transversal. And then you can see that interior are on the inside and exterior on the outside. They're two separate ideas you have to pay attention to. You have to find out whether they're on the inside or the outside, and then what their relationship is with the transversal. So two different things to pay attention to. We're going to revisit old relationships, all right? We're introducing new relationships now, but you still need to know supplementary, complementary, vertical, and linear pair. So if you look at your picture, you should know 1 and 6, 5 and 2, 3 and 8, 4 and 7. Those are all vertical. You should remember those relationships. We also have a lot of linear pair angles. Remember that linear pair angles are just any angles that create a line when you put them together. So 5 and 6 create a line, 1 and 2 create a line. You could switch it up and go this way. 1 and 5 create a line, 6 and 2 create a line, and then same thing with these angles here. So we have a bunch of linear pairs in the picture. So make sure you know the new stuff and you remember the old stuff too. Alright, now we're going to make the picture a little bit more complicated. I have a couple of hints for you guys. Again, once you start throwing more lines into the picture and it looks more complicated, the color coding that I was illustrating here becomes really helpful. So I do recommend you guys use colors. You want to highlight the two lines that are being crossed with one color and the transversal with another color. Typically, I mean, if you want to use the same color for all of them, that's okay too, but it is helpful to use different color for both of these. And doing that helps you narrow the scope of the diagram. Another way you can do this is just redraw the diagram. So let's say you didn't want to use this line right here. You could just redraw the diagram and take all this stuff out. That's another strategy. And then when you're trying to spot alternate interior angles specifically, if you can draw a Z shape, like this, if you can draw a Z kind of shape, the corners of your Z, like this, those are going to be alternate interior. This is a really helpful strategy when your pictures are super complicated or when they're inside of polygons, which we'll see in Chapter 8 and a little bit further into this unit. If you can draw that zigzag Z shape, the corners of your Z are always going to be alternate interior. So that's a cool trick you guys can use to find alternate interior in your diagram. Alright, so what we're going to do is we're going to go through these angles, we're going to look at the picture and see what their relationship is. Alright, angle 1 and angle 5. Now the way that you know what to highlight is you're going to look for angle 1 and you're going to look for angle 5, which is right here. What you're going to do is you're going to find the transversal first. The transversal is the line that both of the angles are resting on, or that both of them are touching. So notice that this line right here, the 5 and the 1 are both resting on this line. Okay, so this is the transversal. That means that these are the two lines that we're crossing with the transversal. So now we have our H shape that we were familiar with on the other side of the page when we were introducing the definitions. So now take a look. I see angle 1 is right here. Angle 5 is right here. Those angles are corresponding. This is in the upper left-hand corner. This is in the upper left-hand corner. So those are corresponding angles. Alright. I'm just going to keep erasing and re-highlighting stuff to illustrate this for you guys. 9 and 3. 9 is right here. Sorry, 13. 9 is right here and 13 is right here. The line that they are both resting on is this one right here. 13 is resting on this line and 9 is resting on this line. So the two lines, two lines I need to highlight would be this one and this one. And then I'm looking at angle 9 and angle 13. These two angles are interior. They're inside of the two lines, they're interior, and they're on different sides of the transversal. They're diagonal from each other. So based on that information, I know that they are going to be alternate interior angles. Alright, next one. 6 and 16. 6 is over here in this intersection, and 16 is over here in this one. They don't have any lines in common, so this one is actually going to have no relationship. If they don't have a line in common, they don't have a transversal, and if they don't have a transversal, there's no way that you can find any of those relationships we were talking about. So if they don't have a line in common, you would just say that they don't have a relationship. Alright, 2 and 15. 2 is right here and 15 is right here. The line that they are both resting on is this one right here. Right? And the two lines that this line is crossing is this one and this one. Okay, you can see that when you trace this line, it's crossing this and this. So I have angle 2 and I have angle 15. So you'll notice that these are interior. They are inside of the two lines, right? So they're interior, but they're on the same side of the transversal. They're not diagonal. They're level with each other. They're on the same side of the transversal. So with those two ideas together, it means that these are consecutive interior. They were interior angles on the same side of the transversal, consecutive interior. Okay. Next one, 8 and 11. 8 and 11 are both resting on this line, and they are, or sorry, that's the transversal. And the transversal is crossing these two lines. I'm looking at angle 8 and angle 11. Right? I notice that these are exterior angles. They are outside. These are inside. These are outside. So they're outside of the two lines that I have crossing, but they are on the same side of the transversal. So because they are outside, that means that they're exterior angles. And because they're on the same side of the transversal, that means that they are consecutive. So 8 and 11 would be consecutive exterior. Oopsie, hold on. Did not mean to do that. I can erase this easier, I think. There we go. Alright. Angle 4 and 14. 4 is right here, 14 is right here. The line that they are resting on is this one right here. And that line is crossing these two. So I'm looking at 14 and 4. I notice that they are both exterior because they're outside of these two lines. So they're both exterior, and they're diagonal from each other on different sides of the transversal. So that means that they are alternate exterior. Alright. And then delete. Okay. Then we have 5 and 9. I'm not going to I'm going to do these a little faster. I'm not going to trace. This is the line that they have in common. And the line that they're crossing, or the lines that they're crossing, are these two. Alright. 5 and 9 are here and here. This is in the upper left-hand corner. This is in the upper left-hand corner. So those two are corresponding. Okay. And then 12 and 5 are both on this line right here. And that transversal is crossing this line and this line. But when you take a look, notice that 5 is on the outside of these two lines, but 12 is on the inside. Okay? But they're alternate. So there's no such thing as having one on the outside and one on the inside and still being alternate. There's no relationship that exists like that. So angle 12 and angle 5, even though they do have that same resting line, that same transversal, they don't have a relationship because one is exterior, one's interior, but they're not aligned properly. I know that for corresponding, one of them is exterior and one of them is interior, but they're both on the same side of the transversal, which makes them corresponding. If they're on different sides of the transversal and one's inside, one's outside, that's not a relationship. Alright, let's take a look at a slightly more complicated diagram here. This is where color coding is going to be even more helpful for you. So I'm looking for angle 1 and angle 13. So you can kind of see that these two angles are resting on this line right here. But what's different about this diagram is that 13 only needs one other line to create this angle, but angle 1 needs two other lines to create the angle. So when this kind of situation happens, this actually means that they don't have a relationship. If you need to add an extra line, like if I were to continue drawing, it would be these two lines would help us, but if you have to throw another line in to create the angle, it throws off the entire system. You should only need the transversal and then two lines. If you need to throw another one in there to create the angle, then you're not going to have one of these relationships. All right. 4 and 11, those are both resting on this horizontal line right here. Oh my goodness. 4 is right here and 11 is right here. So this is our transversal. The two lines that that transversal is crossing to help us create the H kind of shape that we need would be this line. This line. Now it is true that the transversal is also crossing this line, but this line does not help us at all to get the 4 and the 14 to have a relationship. So we're going to pretend this line isn't here. So I'm looking at angle 4 and angle 14. If you take a look at just what I've highlighted, you'll notice that 4 and 14 are both in the lower left-hand corners of the intersections, which means that they're in matching positions. Oh, I'm sorry, we weren't doing 14. That's my bad. We were supposed to be doing 11. That's why the answer is weird. Hold on, let me see if I can... There we go. My apologies. So now we're, instead of looking at 4 and 14, which are corresponding, we're looking at 4 and 11. So both of these angles are outside of the two lines that we trace here. So that means that they're exterior. And they're on the same side of the transversal, which means that they're consecutive. So that's why this one is, oops, this one is consecutive exterior. They are on the same side of the transversal, but they are both outside of the two lines. All right, sorry for mixing that one up. Now we can take a look at 5 and 8. So 5 is right here, and 8 is right here. The line that they are both resting on is this one. So 5 is resting on this line, so is 8. The two lines that the transversal is crossing that we're going to use is this one and this one. And again, we're looking at 5 and 8. So notice that they are both in the lower corner on the left side of the transversal. So lower left-hand corner. They're in the same position in both intersections, so I would make them corresponding. Now we're going to take a look at 2 and 12. So the line that they are resting on is this line right here. The two lines that the transversal will be crossing in this situation would be these two. We're looking at 2 and 12. So hopefully you see this a little bit more quickly. This is another set of corresponding angles. They're both in the upper right-hand corner of both of these intersections. They're in matching positions, but in different spots in the diagram. So that makes them corresponding. We have, I'm going to use a different color because this is boring. All right. We have 9 and 14. So the line that both 9 and 14 are on is this one. So this is our transversal. Remember, the transversal is the line that the two angles are resting on. Okay. Now, the two lines that we need to create the rest of our shape are going to be the two lines that are going to help us create the angle. So to create angle 9, I have to use this line. And to create angle 14, I have to use this line. Now, I know this isn't our typical H that we've seen before. It would have been an H if I kind of swung this line out here a little bit. It would have created an H. But I've tilted it in a little bit more so that they cross instead of making an H. But we still have relationships between these angles. If I take a look at 9 and 14. We still want to consider these two lines for whether our angles are inside or outside. So notice how 14 and 9 are both in between or inside of these lines. So these are interior angles because they're on the inside. Exterior angles would be out here and out here. But these are inside of the two lines. So these are interior. And then this was our transversal from before. Notice how they're diagonal from each other. They're on opposite sides of the transversal. So if they're on the inside and they're on opposite sides of the transversal, that makes them alternate interior. They're interior and they're alternate. But we always put the interior, exterior last in the definition. So you can still find this stuff when the lines are crossing, when it's not an actual H. You can still find the information when the lines have sloped a little bit more to cross each other. All right, 6 and 10. 6 and 10 are both resting on this line. And the two lines that I need to create angle 6 and angle 10, I need this line right here to help me create angle 6. I need this line right here to help me create angle 10. So we have another situation where it's more of an A than an H, but we can still think about it the same way. So these are our two lines right here. 6 and 10 are inside, right? These are all inside of the two lines. So we have interior, but they're on the same side of the transversal. They're both above. They're consecutive. They're next to each other. So that would make 6 and 10 consecutive interior. All right? Then we just have one more. So 2 and 14. 2 and 14 are both resting on this line. So this is the transversal. And then the two lines I need to create angle 2 and 14 are those two angles, or those two lines right there. Again, you find the other two lines by finding the lines that the transversal is crossing. That will help you finish creating the angles that you need. So if we take a look, 2 and 4, these are both in between the two lines, so they're interior, but they're on different sides of the transversal. They're diagonal from each other. So that would make them alternate interior. So being able to identify these relationships is really, really important. So make sure that you go back and review your notes a lot, get some more practice online, Google the different relationships to get more practice. If you don't understand the relationships, then solving using the relationships is going to be really difficult for you. So make sure that you are 100% good with this lesson.